Hi sir, my name is Nandini Vijay. Now I'm going to explain part 1, which is an inverting amplifier. The inverting configuration creates the negative gain, meaning that one circuit can both amplifying a signal and change its polarity from positive to negative and negative to positive. And also the input signal is applied to the inverting negative input. The negative input provides 180 phase shift between the input and output signal. So I already calculate the V out and gain, average gain. So I get -5 and -5. So this is my output when my R1 is 20 kilo ohm. So when I replace the R1 to get the gain -1, so the suitable resistor is 100k to get the gain in -1. So I replace it 100k. So I get 1. So my calculation value also I get 1. Thank you, sir.
Assalamualaikum. My name is Nur Azrin Atika binti Zulkifli. I will explain for part 2, which is non-inverting amplifier. This is the circuit for non-inverting amplifier. Okay, in this configuration, the input voltage signal, here is the input voltage signal, is directly applied to the input terminal of op-amp. Okay, we will run. Here is 20k. Okay, we will run this circuit to see the waveform. Okay, here. Okay, to measure the input and output voltage, this is how to measure the input and output voltage. So for the blue waveform is the blue waveform is the output voltage, and the red waveform is the input voltage. So here we will measure. Okay. Okay, why the output voltage is, the amplitude is bigger than the input voltage? Because the function of op-amp is to amplify the input signal, so it will become more bigger than the input signal. Okay, for the input voltage, here is the value for input voltage, and here is the value for output voltage. So the value for input voltage is in negative, and the value of output voltage also in negative. So the voltage gain, the formula for voltage gain is V out over V in. So it will get in positive value. We will get the voltage gain in positive value. And then measure the phase difference. Here we can see the output signal is in phase with this is output. The output signal is in phase with the input signal. So there are no phase difference between output signal and input signal. This is the formula to calculate the non-inverting amplifier, which is 1 plus RF over R1. Okay, that's all for part 2.
Assalamualaikum warahmatullahi wabarakatuh. I am Nili Nofianti binti Sabudi from BEEE section 1/1. So today I would like to explain about lab 1, which is the application of op-amp. I am going to explain part 3 specifically, which is summing amplifier. I already constructed the circuit based on the question given. Okay, as for the summing amplifier, the configuration is quite similar with inverting amplifier, which the input is connected to negative. And actually, the summing amplifier can be connected. The input can be connected to negative or positive, depends on the question, and the input can be 2 or more. So this is the summing amplifier, and which the configuration same as inverting. Okay, there will be 2 function generator used, and both of it will be set to the same input value and frequency. So I already set the function generator based on the question given. You can see here. Okay, this is the question. Okay, so I am going to show you the input and output voltage using oscilloscope. Okay, this is my input and output voltage. As you can see here, as for the phase difference, we can see that the waveform between input and output is in inverting state by 180 degrees. Because we are using the inverting configuration. If you are using the non-inverting configuration, the input and output are in same phase. Which mean the input waveform and output waveform is similar, only the value change. Okay, as for the output value, we got 5.98 volts. Okay, so moving to the next question, and the question want us to replace the resistor with suitable value to gain, and the gain will get -2. So I am going to change the R2 to 100k. 100k. Okay, I'm going to replace it. Sorry. Okay, so this is my new input and output waveform. As you can see here, the output value decreased to 2 volt, which means the output value decrease when the resistance values increase. The resistance value is refers to the input resistance. Okay, so if you want to measure the gain, you can just use the formula, or you can just use the value obtained at the oscilloscope. You can just divide VO by Vin. VO by Vin, you can get the answer. Okay, so this is the calculation. Okay, if you want to use the calculation, you can use this formula. You want to calculate. If you don't want to use the simulation, you can use this formula. And if you already use the simulation, you can just divide VO by Vin. Okay, and that's all from me. Thank you.